Today I want to show you how we're going to find equivalent fractions. These are fractions that have the same value, but they have different terms. For example, 2/3 is equivalent to 4/6, which is equivalent to 6/9. Okay, now, but I want to teach our students how to do it, and we use a property called the identity property. And all this means is that I can multiply any number by 1 and I haven't changed the value of that number. The difference with fractions is when I multiply by 1, I'm going to multiply by a fraction. So any fraction that has the same numerator and denominator is equal to 1. For instance, 2 divided by 2, or 2/2, is 1 whole. So when I multiply 2 times 2 for the numerators, I get 4. And when I multiply 3 times 2 for the denominator, I get 6. So this shows us that this in fact is true, and it's mathematically correct because of the identity property. Now, we're going to be working to find many equivalent fractions, and sometimes the terms are much larger than what we start with. So we're going to make what we call an equivalent fraction table. And it's nothing more than combining a whole series of these identity property facts. For instance, 2/3 times 2/2 equals 4/6, as we just saw. Now I can also multiply the 2/3 by 3/3, and I get 6/9. Because 2 times 3 is 6, 3 times 3 is 9. I can also multiply the 2/3 by 4/4, and I get 8/12. So each of these fractions are equivalent, and I could keep going forever. The only thing I have to remember is that when I'm multiplying by 2/2 or 3/3 or 4/4, I'm not multiplying it to the number before. I'm multiplying it to the original fraction. So in a sense, all we're doing is we end up skip counting. We're counting by 2's up here. 2, 4, 6, 8, 10, 12. We're counting by 3's down here. 3, 6, 9, 12, 15, 18. All of these fractions are equivalent, and that's all it takes to skip count. The reason the skip counting works is because of this identity property. So this is all we have to do to make equivalent fractions.